Okay, in the first lesson of this mini unit, we are going to identify functions as being linear, exponential, or quadratic, given a table, an equation, a graph. Then we're also going to be able to identify key features. Also part of that is I'm going to be giving you key features and you're going to tell me which function it has to be. Sometimes it may be able to be more than one. So first of all, let's just recall how we are going to decide if this table is linear, quadratic, exponential. So if you remember, back in Unit 6, we talked about how we distinguish between these functions given a table. The first thing we need to check is to see if our input values are in sequential order. Are they consecutive? And we can see that they are here. So when our input values are in order, from least to greatest, we can always just look at the output values and see what pattern is going on. This pattern will let us know which kind of function it is. So the very basic function we learned was linear. Remember, linear functions have a constant rate of change, which would be your slope. So we're going to ask, how are we getting from 29 to 19 to 11 to 5 to 1? So first of all, always check to see if there's a first difference. So from 29 to 19, it's going down by 10. And then from 19 down to 11 is going down by 8. And then from 11 to 5, we're going down by 6. And then from 5 to 1, we're going down by 4. So we see that this first difference is not constant. So we know it's not linear. So now we check to see the second difference. So that's just the difference between the first differences. So from negative 10 to negative 8 is plus 2. From negative 8 to negative 6 is plus 2. And from negative 6 to negative 4 is plus 2. So there is a constant second difference. So this means that this function table is quadratic. So, and all the patterns that we get from our outputs is going to tell us some part of our equation. So the second difference helps us determine the a value of our quadratic. So if you remember, our second difference, which is 2 in this case, once we divide it by 2, and this gives us our a value. So our a value is 1. So right here we have a value of 1. Okay, let's check this next one. We're going from 32 to 16 to 8 to 4 to 2. Again, our x values are consecutive, no gaps in between. I can already kind of see a pattern that it's not being subtracted. Okay, but I do see a pattern that from 32 to 16, 16 to 8 is going down by 1/2. So we say that this has a constant ratio of 1/2. So when we are multiplying our output by a value, a ratio, then we know that's exponential. So this table is exponential. And this number right here, this 1/2, this is our multiplier. That's the b part. So remember, so our b is 1/2. This means this is a decay. It's decreasing. Let me write here. Our a was 1 here. Okay, our last function table. Again, numbers are going in order. We're going from negative 24 to negative 21. It looks like it is a constant rate, so I'm going up by 3 each time. Okay, so this tells me that this is a linear table. So up here, this first difference, this constant rate of change, is my slope. That's the m value. So in summary, when we have a linear function and our x values are consecutive, it will have a constant first difference, which is our m value, our slope. When we have a function that's exponential and our x values are consecutive, our outputs, if they have a constant ratio, a multiplier, we know it's exponential, and that gives us our b value. Quadratic, our X values, if they're in sequential order and they're consecutive, if it has a second difference, we're going to take that second difference and we're going to divide it by 2, and that gives us the A value. So if you want to take a break and pause, you can pause now, or we can keep moving along. We'll do a few more things and then I will create another video. I'm trying to keep these short. Okay, so I know that it's obvious what these graphs are, but I just want to make sure we use the correct terminology. So we have some linear graphs. These are like scatter plots, but you can see they're linear functions. But this one has a positive slope, so we will call it a growth linear, or a linear that is a growth. The one that's negative has a negative slope. It's going to be considered a decay. Exponential, kind of the same thing. We know this is a growth. That meant our B value was more than 1, and it was being multiplied and growing exponentially, while our decay, we had a B value between 0 and 1, like 1/2 or 1/3, and it's being divided, and gets closer and closer to our asymptote, and this is a decay. For the quadratics, we don't use growth or decay to describe, but we just describe the vertex. So here we have a quadratic whose vertex would be a minimum point. This one, we have a vertex that would be a maximum. So on this one, our A value would be negative. On this one, our A value would be positive. Over here on the linear growth, our slope, our M, would be positive. Our decay, our slope would be negative. Okay, so we've taken a look at tables to know which function is which, graphs. Now let's look at some equations. So a lot of times you have to kind of evaluate to see exactly what kind of equation. So I am just going to distribute and then combine. I'm going to write it in standard form. And so we can see that this is linear because I have an exponent of 1, and it is a decay. So it's a decay and it's linear. Okay, let's distribute our negative x. So we're going to get negative x squared plus 8x plus 4. That is in standard form. We can see that it's quadratic. And our quadratic turns down. So our vertex would be a maximum. And then here we can see, well, there's nothing really to simplify, but I am going to write this in standard form. And we can see it's exponential. And since our B value is between 0 and 1, it is a decay. It's getting, we're just dividing by 2, dividing by 2, dividing by 2. Okay, now we're going to get into some key features, and really we're about done. So I'm just going to keep going instead of making some mini videos. Again, you can just pause and come back to this. Okay, so here I'm given some key features and I have to determine. So I'm going to do a little sketch. So we know that our domain, most on all these functions, the domain is going to be all real numbers. So it's all about the range. Now this range is saying that my 2 is included. So I am going to assume that this is going to be quadratic, and then it turns down like this, and that the range 2 is the, no.